Welcome to the deep dive. Today, we're looking at a company that, for decades really, has been the powerhouse behind the most intense, most demanding graphics you see in computing. If you were a serious gamer back in the day, you absolutely knew Nvidia.
Oh, absolutely. They were the ones making smoke look real, making shadows believable in games like Quake, Doom, very niche in a way, but in this incredibly volatile chip sector where things change, like overnight.
Uh-huh. But now, it's totally different. Nvidia isn't just for gamers anymore. They're the foundational supplier, the premier supplier of these advanced processors, these GPUs, that are basically fueling the entire age of AI.
It's just an incredible climb. I mean, this isn't just staying alive, it's total dominance. They've blown past almost everyone else in the chip world, a true titan, basically selling the picks and shovels for this huge generative AI gold rush we're seeing.
So our mission today is really to unpack how they did that. How did they achieve that longevity, that dominance? We're digging into what's called the Nvidia Way, this unique mix of company structure, intense work culture, and, critically, the vision of CEO Jensen Huang.
Right, the longest-serving tech CEO currently out there. He guided this company for 3 decades, navigating some really near-death moments.
We should probably start right at the beginning with the founding in 1993. There was this essential trio, this founder's triangle that really set the stage.
Yeah, you needed all 3 pieces. First, Jensen Huang. He brought that aggressive business sense, that relentless management style that still defines NVIDIA today.
And then the tech brains. Curtis Prime, he was the chip architect, right? Obsessed with graphics performing there.
Exactly, always pushing the limits. And then Chris Malachowski, the build-it guy, he had the crucial engineering and manufacturing know-how to actually make Preem's often ambitious, sometimes risky, chip designs into something real, something they can sell at scale.
So vision, architecture, execution, all driven by Huang's intensity. It's a classic setup.
Absolutely.
Okay, let's dig into Jensen Huang himself first, because his backstory seems so crucial to understanding the NVIDIA culture. Our sources keep linking his management style back to his early life, which he himself described using words like pain and suffering.
Yeah, it's a really compelling narrative. He was born in Taiwan, lived in Thailand for a bit, and then, this is in the 70s, he and his older brother get sent to Tacoma, Washington, to live with relatives.
And even before they moved, his mother had this intense focus on learning and hard work.
Oh yeah, this daily ritual. She'd pick 10 random dictionary words, and the boys had to spell them, learn the definitions, memorize them every single day.
Wow. That's not just teaching English, that's instilling a system. Rigorous daily effort, incredibly high expectations right from the start.
It totally sets a standard for what's considered acceptable performance, which is, maximum effort. But then comes this really unexpected, maybe the most formative experience. His parents wanted a good American education for them, so they sent the boys to what they thought was a fancy private prep school in rural Kentucky.
But it wasn't a prep school at all, was it?
No, not even close. It was the Oneida Baptist Institute. It was basically a reform school for troubled kids. You can imagine the shock, right? Young immigrant kids showing up there.
That must have been incredibly jarring. And his parents had sacrificed a lot to send them there.
They'd sold almost everything, thinking it was this prestigious place. Instead, it's super strict, structured, designed for kids who were at risk or had problems. And a big part of life there was manual labor. Jensen's chore was janitor duty for his entire 3-story dorm.
Including cleaning the bathrooms.
Including cleaning the bathrooms. He joked later, you can't unsee that kind of stuff. It builds this baseline tolerance for discomfort, for doing the hard, unpleasant jobs that just have to be done.
Yeah, you don't hear many Silicon Valley CEOs talk about cleaning dorm bathrooms as a key life experience. But that tolerance, it became critical because he wasn't just dealing with chores, he was dealing with bullies too.
Right, a young kid, obviously a target. And this is where you start to see that street fighter mentality emerge, as people later called it.
How did he handle that? It sounds like an incredibly tough environment.
He had to get tough fast. He actually became friends with his roommate, this older kid, like 8 years older, covered in tattoos, apparently had knife scars, looked really intimidating.
Okay.
So Jensen, the academic kid, starts teaching this older guy how to read. And in return, the roommate taught him weightlifting, gave him some protection, and maybe, crucially, the confidence to stand up for himself.
So he basically traded tutoring for protection and self-confidence. It makes sense that his executives later pointed back to this time as the root of that tough, almost combative business style.
It really cemented this idea that you have to be tough to get by. He put it pretty bluntly later. I will never start a fight, but I will never walk away from one. So if someone is going to pick on me, they better think twice. That whole period, the hard labor, the conflict, needing to adapt constantly, it built this foundation where pressure wasn't something to avoid, it was something you almost welcomed.
And that attitude, that pride and hard work, it continued when he moved to Oregon, right?
Yeah.
Working at Denny's from age 15.
Yep. And this is where you see that drive for excellence applied to, let's be honest, pretty mundane jobs. Started as a dishwasher, cleaning more bathrooms, he quipped, then busboy, then waiter. And he claimed he was the best dishwasher, the best busboy, the best waiter they ever had.
It's about holding yourself to a high standard no matter the task.
Exactly. Effort is universal. But even then, at Denny's, you see these early signs of his strategic thinking about efficiency. The famous milkshake story.
Yes, the milkshakes. Explain that one.
Okay, so he hated making milkshakes. Why? Because they took a long time to prepare, and the cleanup was sticky and slow. It messed up his workflow.
Right.
So what did he do? If a customer ordered a milkshake, he'd actually try to steer them towards, like, a Coke or something easier. He was already balancing customer service with operational efficiency, even as a teenage waiter.
That's fascinating. He recognized that even high standards need to be efficient, a trade-off he'd definitely apply later in the complex world of chip design, where time and resources are everything.
Precisely.
So that determination eventually got him into the semiconductor industry. His first job at AMD, designing chips, he found kind of tedious.
Yeah, too manual. He then moved to LSI Logic, which was pioneering using software tools for chip design, much more his speed. And crucially, while working on their Sun Microsystems account, he met Curtis Prime and Chris Malachowski.
The other 2 points of the founding triangle. Prime was already a known quantity in graphics.
Oh yeah, he designed the IBM Professional Graphics Controller, the PGC, way back in '84. At Sun, he and Malachowski were kind of this rogue team working in secret. They call them the closet graphics guys.
Closet graphics? What were they hiding from?
They were essentially defying their VP of engineering, a guy named Bernie Lecroute. Lecroute was adamant that Sun's Spark Station should focus only on the CPU, letting the main processor handle graphics.
But Priem and Malachowski knew better.
They saw the future. High-performance, beautiful color graphics stuff the CPU just couldn't handle well, so they secretly built this high-performance graphics engine, the GX accelerator, basically behind their boss's back.
And it worked.
It worked incredibly well. Priem talked about how text scrolling was faster than you could see. It really showed the power of dedicated graphics hardware.
But success inside a big company can sometimes create its own problems, right? Politics.
Exactly. It just amplified the internal dysfunction at Sun. Priem started finding the culture really toxic. He felt rivals were spending more energy trying to sabotage his projects than innovate themselves.
And the breaking point came when he lost a bid for a new chip design.
Yeah, he lost out to a rival, Timothy Van Hook, who apparently had the ear of one of the Sun co-founders, Andy Bechtolsheim. Priem felt, in his words, chastised and brutalized by management. That rejection, plus Malachowski being loyal and equally frustrated, pushed them to leave Sun.
Initially, they were just going to consult.
That was the plan. But their conversations quickly evolved. They started sketching out the idea for a startup focused on building the kind of graphics accelerator that Sun had just rejected.
And this brings us back to Denny's. These legendary planning sessions happened in a back booth in East San Jose.
That's the story. Over endless cups of coffee and probably a few grand slams or superbirds. Jensen, remember, he actually liked his job at LSI Logic, felt secure. He wasn't itching to jump.
So he needed some convincing.
Big time. And he brought that Denny's efficiency mindset to their ambition. He laid down a challenge. Prove to me this startup can realistically hit $50 million in annual sales. Only then would he quit his job.
$50 million. That's a huge number for a chip startup back in the early 90s.
It was a massive target, a reality check. Priem took the leap first, quitting Sun in December '92. That put the pressure on. Jensen finally committed, joining on his 30th birthday, February 1993. He'd become convinced that the PC market, especially gaming, was about to explode, and that $50 million was actually possible.
And the name they eventually chose, Nvidia, that also speaks volumes about their ambition.
It really does. Their first chip was planned as the NV1 for next version. Priem apparently looked up the Latin word for envy, Nvidia. They liked the sound, dropped the I to connect it to the NV1, and landed on Nvidia.
So right from the name, the goal was to be envied.
Consciously. A statement of intent from day one. They wanted to build something everyone else would covet.
Okay, so the ambition was there, the founding team was in place. But those early days, They sound absolutely terrifying. They got Series A funding, but base more on Jensen's reputation than any actual product.
Pretty much $2 million. And the legendary venture capitalist Don Valentine from Sequoia Capital apparently told Jensen, if you lose my money, I will kill you. So, no pressure.
Just a little light motivation to start your company. And that pressure got real very fast with their first actual chip, the NV1. It was almost a fatal mistake.
Almost. A strategic miscalculation, maybe driven by a bit of technical arrogance. It launched, or was announced, in May 1995.
What went wrong? It was supposed to be this all-in-one multimedia solution.
Yeah, the Swiss Army knife approach.
Yeah.
Two huge mistakes. First, they tried to jam video and audio onto one chip. And this was critical, it wasn't compatible with Sound Blaster.
Which was the standard for PC game audio.
Exactly. If your games didn't sound right, gamers wouldn't touch it. Dead on arrival for the core market.
And the graphics side had its own major issue, something about triangles.
This was the core technical blunder. The whole 3D graphics world was moving towards rendering using standard triangles. It's efficient, flexible. Nvidia, though, used this proprietary approach based on quadratic surfaces, sometimes called inverse triangles.
Why? What was the thinking there?
They believed it was mathematically more elegant and, crucially, used less onboard memory, which was really expensive back then.
But being proprietary meant developers ignored it.
Completely. It was a closed system. Games looked terrible on it because they were optimized for the standard triangle method. It was like Betamax versus VHS, but maybe even worse because the quality suffered immediately.
And then the economics turned against them, too.
That was the killer blow. They designed it to save on expensive memory. And then almost overnight, memory prices just crashed. From like $50 a megabyte down to $5.
Ouch. Their main design advantage just evaporated.
Instantly. Gone. The result was a disaster. Diamond Multimedia, their main partner, had ordered 250,000 chips. They ended up returning almost all of them by early '96. Nvidia had burned through something like $15 million.
So they're bleeding cash. The first product is a flop.
And then Sega pulls the plug on the contract for their next chip, the NV2, which is supposed to go into a console. Things looked incredibly bleak. They had to lay off most of their staff, down to just 40 people.
It sounds like they were done for, but they survived. How?
Jensen's foresight in contract negotiation. The Sega clause.
The Sega clause. Explain this.
Even though Sega canceled the main NV2 contract, Jensen had insisted on a clause way back when. It guaranteed Nvidia a $1 million payment if and only if they could produce a working NV2 prototype chip on a motherboard the size of the old Sega Genesis console.
That sounds like a very specific, almost random requirement.
It does. But an engineer, after like a year of grinding away, finally got it working and triggered that payment, that $1 million. That was their lifeline. It was just enough cash to keep the lights on and fund the development of their next chip, the make-or-break NV3.
Wow. Saved by a contract detail. Okay, so they're down but not out. Meanwhile, the competition isn't waiting around.
Not at all. A new rival, 3DFX, founded by guys from Silicon Graphics, had just launched Voodoo Graphics in '96. And it was hot. It brought high-end SGI-level 3D graphics to regular PCs for like $299.
And 3DFX thought NVIDIA was finished?
They were apparently convinced NVIDIA's bankruptcy was just a matter of time. They basically wrote them off.
So NVIDIA has this tiny lifeline of cash, maybe 9 months of runway left.
And they have one shot.
Yeah.
Create the absolute fastest graphics chip the world had ever seen. Jensen greenlit Curtis Prime's super aggressive design for the NV3, which they branded the RVA 128.
What made it so aggressive?
It was physically huge for the time, packed with 3.5 million transistors, and it had the industry's first 128-bit memory bus, double the width of anything else out there. It was a massive bet on raw speed and bandwidth.
And this is where Jensen really puts that speed of light idea into practice with a very risky decision.
Extremely risky. He decided to spend $1 million, a third of their remaining cash, basically 3 months of payroll, on this machine called an ICOS chip emulation system.
Why? What did this machine do that was worth betting the entire company on?
It allowed engineers to simulate and test the chip's design digitally, extremely fast, before they even had physical silicon prototypes. Normally, you'd wait for the physical chip, find bugs, fix them, make new chips. It took forever.
So this ICOS machine let them skip a huge chunk of that slow, iterative process.
Exactly. Jensen argued, look, investors have plenty of other companies they can back. We only have one shot. This machine lets us move faster. It was a gamble that traded cash runway for development speed.
And it enabled this radical change in their workflow.
Completely radical. Because they could simulate the chip accurately, the software team, led by Dwight Dirks, could start writing and debugging the device drivers before the physical Rivio 128 chip even existed.
That sounds backwards. Normally, software waits for hardware.
It was completely backwards, but it shaved almost a year off their development timeline. It was so successful, Jensen made it standard practice for every chip launch afterwards. Speed of light.
So they raced to get this thing ready for the big showcase, the 1997 Computer Game Developers Conference. And it sounds like it was down to the wire.
Oh, it was pure chaos behind the scenes. The actual physical chip samples only arrived days before the show. A sales manager later admitted the chip was barely stable. It could run the key performance benchmark maybe once before crashing.
Not exactly confidence-inspiring.
Not at all. But then Scott Sellers, one of the co-founders of their big rival 3DFX, walks up to the Nvidia booth, kind of skeptical.
What did Jensen's team do? Did they just pray it would work?
They put on a show. They said, oh, let's reboot the system for you, get you a nice clean run. Total bluff, basically buying time and hoping it held together for one more benchmark.
And did it?
It did. The numbers came up, and they were apparently astronomical, unprecedented. Sellers from 3DFX immediately realized this company they dismissed as dead was, in his words, roaring back.
What was the reaction from others in the industry?
Just as dramatic. A chief architect from a rival company, Walt Donovan, saw the results, walked over, and basically asked for a job on the spot. They hired him right there.
Incredible. So the gamble paid off.
Massively. The Rivia 128 shipped over 1 million units in just 4 months. It grabbed a fifth of the entire PC graphics market, and it gave Nvidia its very first profitable quarter.
And that's when Jensen did the symbolic thing with the dollar bills.
Yeah. After that first profitable quarter, Q4 1997, he handed every single employee a crisp $1 bill.
Why? What was the message?
It was a physical reminder of that $1 million lifeline from Sega. A reminder that even with this huge success, they had been just 30 days away from total collapse. The message was clear. Never get complacent. Success is fragile.
Okay, so they dodged the first bullet with the NV1, came roaring back with the Rivia 128, but that wasn't their only near-death experience, was it? There was another major crisis later on.
That's right. Less talked about maybe because it happened after they went public, but arguably just as dangerous. This was the GeForce FX series, based on the NV30 chip, around 2003.
What went wrong this time? They were dominant by then with the GeForce line.
Hubris, essentially. Architectural hubris. They got obsessed with winning benchmarks, specifically hitting higher and higher clock speeds. They thought speed was the only thing that mattered.
So the NV30 chip was fast.
It was designed to be incredibly fast, yes. But to achieve that speed, the chip itself became physically enormous and incredibly power-hungry. It ran HOT.
Like actually hot.
Blisteringly hot. So hot that the graphics cards needed these huge, loud, complex cooling fans.
Yeah.
And the power requirements were off the charts. It just wasn't practical for mainstream PCs.
So it wasn't just about performance, it was about usability. Like, could manufacturers even put this thing in their computers?
Exactly. It failed the basic thermal and power tests for many big manufacturers. Dell, a huge partner, threatened to ditch them entirely. The competition, especially ATI at the time, just ate their lunch. Nvidia's market share cratered, their reputation took a massive hit.
Wow. So they were facing potential bankruptcy again, but this time because their own design was fundamentally flawed for the market.
Right. Not a lack of money this time, but a failure of architectural vision, you could say. It forced this huge internal crisis. Jensen had to basically issue a public mea culpa and lead a frantic redesign effort.
What was the lesson learned there?
Painful, but vital.
Yeah.
You can't just chase one metric, like clock speed, blindly. Performance has to be balanced with power efficiency, with heat, with cost, with manufacturability. It has to be practical. Surviving two of these existential crises, first the NV1 financial disaster, then the NV30 architectural disaster, that's what really forged that culture of absolute rigor and paranoia that defines them.
Okay, so surviving those near-death moments wasn't just luck. It forced them to build systems and a culture to prevent it from happening again. This leads into how they moved from just surviving to actually building sustained dominance.
Exactly. And the absolute core of that was taking the lesson from the RVA 128 recovery, that speed of execution, and turning it into a permanent strategy.
The 3 teams, 2 seasons idea.
That's the one. Before NVIDIA, chip companies typically worked on roughly an 18-month cycle for a new generation. By the time your competitor's chip came out, yours was already feeling old.
And Jensen wanted to shatter that cycle.
Completely. The goal was to launch 3 major chip architectures in that same 18-month time frame. Essentially, a significant new chip hitting the market every 6 months
How do they manage that?
by having 3 distinct design teams working in parallel on staggered schedules. Team A is finishing a chip, Team B is midway through the next one, Team C is starting the one after that.
So there's always something new in the pipeline ready to go.
Always. If one team hits a snag, or if the market suddenly shifts, like with memory prices or a new software standard, they weren't caught flat-footed. They had another chip, maybe slightly different, but nearly ready. Jensen called it ensuring competitors were always shooting behind the duck.
Meaning by the time a rival launched a chip to compete with Nvidia's current offering,
Nvidia was already 6 months ahead, launching the next one. It created this relentless pressure, forced everyone else to play catch-up, and made PC makers hesitant to switch away from Nvidia, because something even better was always just around the corner.
but speed wasn't everything, as the NV30 disaster showed. They also needed absolute quality. This is where Jensen's second place is the first loser mantra comes in.
Precisely. After the Rivi 128 launch, even though it was a huge success, it did have some image quality issues, things like dithering, smoke effects looking a bit blocky in some games. When a magazine review pointed this out, putting them second in image quality even if they won on speed.
Jensen wasn't happy.
Not remotely. He basically declared that second place was unacceptable. Nvidia chips had to win on every metric. Speed, image quality, features, efficiency, no compromises. That relentless demand drove the improvements in the Rivi TNT series and laid the groundwork for the first GeForce chips, which really cemented their quality reputation.
And part of maintaining that edge was being incredibly aggressive about talent acquisition, even poaching from rivals and partners. The story with SGI engineer John Montrim is pretty bold.
It's classic Jensen, really. SGI was the established giant in high-end graphics back then. Jensen, leading this much smaller upstart, basically tells Montrim directly, look, ultimately, I'm going to put SGI out of business. You should come work for us.
That takes some serious confidence, or maybe arrogance.
A bit of both, probably. But to back it up, Jensen had his engineers create this custom graphics demo specifically to recruit Montrim. It replicated the capabilities of SGI's flagship multi-million-dollar reality engine system running on Nvidia's much cheaper hardware.
Just to prove they could do it?
Just to prove they had the technical vision and the chop to take on the king, Montrim was convinced and joined.
And inevitably, SGI sued them over patents related to the tech Montrim brought.
Of course. But Jensen spun it into a motivational moment for the company. He apparently walked around shaking hands saying, "Congratulations. We just got sued by the most important graphics company in the world. We're finally somebody."
Turning a lawsuit into a badge of honor, validating their aggressive stance.
Exactly. It showed they were now a real threat playing in the major leagues.
Okay, so they've got speed, quality, talent. The next big strategic leap was actually defining what they were selling, moving beyond just graphics cards to branding the GPU itself.
Right. This was a critical marketing and technical shift around the launch of the GeForce 256 chip. They realized these technical acronyms like Rivi TNT weren't really communicating the power or importance of what they were building.
So they brainstormed a new name.
Yeah. And they landed on Graphics Processing Unit, or GPU. The key here was explicitly positioning it as a parallel to the CPU, the Central Processing Unit.
That's clever. It implies it's not just an add-on card, but a coprocessor, something fundamental to the computer's power.
Precisely. It elevated the chip status, justified a higher price point closer to what CPUs commanded, and started educating the market that graphics processing was a distinct, critical workload.
But it wasn't just marketing spin. The technology underneath was evolving too, particularly with the push for programmable shaders, led by Chief Scientist David Kirk.
Yes, this was hugely important, starting seriously with the GeForce 3 in 2001. Kirk saw a massive strategic threat on the horizon.
Which was?
Intel. Kirk worried that if Nvidia just kept making chips that performed a fixed set of graphics tasks, what they call fixed function hardware, eventually Intel would just figure out how to do those same basic tasks well enough, shrink the logic down, and embed it directly onto their CPUs or motherboards for free.
And Nvidia's whole business model would disappear, the classic innovator's dilemma.
Exactly. So Kirk argued passionately for programmable shaders. This is a radical shift. Instead of the GPU only doing predefined tasks, it opened up parts of the graphics pipeline to be programmed directly by game developers.
What does that mean in practical terms?
Think of it like this. A fixed function chip is like a kitchen appliance with only a few buttons: toast, bagel, defrost. A programmable shader chip is like giving the developer a whole programmable chef's knife. They can invent entirely new ways to slice, dice, and combine ingredients, create visual effects and techniques that Nvidia hadn't even thought of.
So it makes the GPU indispensable because developers can constantly innovate on top of it, creating effects Intel's basic integrated graphics could never replicate.
That's the core idea. It future-proofed the GPU, kept it separate and essential, and crucially, opened the door to using the GPU for tasks beyond graphics, which became incredibly important later. The GeForce 3, the first true GPU with these capabilities, was an absolute blockbuster. It helped Nvidia hit $1 billion in annualized revenue faster than any other semiconductor company in U.S. history up to that point.
And winning market meant winning the toughest customers, like Steve Jobs at Apple. How did they crack that?
That required a bit of showmanship and nerve. The sales team, led by Dan Vivoli and Chris Diskin, needed a killer demo for Jobs to win the Power Mac G4 business. They used Pixar's famous Luxo Jr. animated short, The Little Hopping Lamp.
Okay.
Initially, Jobs watched it and was like, okay, nice video. He thought it was just pre-rendered playback. The magic moment was when Vivoli grabbed the mouse and started dragging the view around, changing the camera angle, adjusting the lighting in real time.
Proving the GPU wasn't just playing a movie, it was generating those complex Pixar-level graphics live.
Exactly. It blew Jobs away. That demo sealed the deal for the Power Mac G4. But the relationship wasn't always smooth sailing. Later, Jobs apparently challenged Nvidia's performance on laptops, saying rival ATI was better on power efficiency.
And how did Nvidia respond?
This is where Chris Diskin showed that Nvidia's Street Fighter DNA. Instead of backing down, he directly told Steve Jobs, actually, Steve, I think you're wrong.
Wow, you didn't generally tell Steve Jobs he was wrong.
You really didn't. But Diskin argued Nvidia's chips were only using more power because they had so much more performance capability. Massive headroom, he called it. He claimed they could easily tune the power down to match or beat ATI while still having superior performance potential.
And Jobs bought it.
He was apparently impressed by the directness, the confidence. He scheduled a deep dive review the very next day, and the result. Within a few years, Nvidia went from basically zero presence in Apple's lineup to having something like 85% market share across their computers. They proved they had the tech and the guts to defend it.
Okay, so programmable shaders were key. And that programmability, that flexibility, directly paved the way for what might be their single greatest strategic asset today, CUAD.
Absolutely. CDA Compute Unified Device Architecture is the moat. It all started when researchers began realizing these GPUs, designed for pushing pixels in games, were actually incredibly powerful parallel processors. They started hacking them using graphics languages in weird ways to run scientific computations, stuff like protein folding simulations, financial modeling. They called it GPGPU, general purpose computing on GPUs.
But it was hard to do, right? You had to think like a graphics programmer.
Incredibly difficult and niche. Jensen saw the potential early on, especially in areas like medical imaging. But the friction was too high for widespread adoption. CDA was the answer.
What did CDA do differently?
It created a dedicated software layer, a platform, that let programmers use the GPU's massive parallel power using extensions to standard, widely known programming languages like C. Suddenly, you didn't need to be a graphics wizard to harness the GPU.
So it made parallel computing accessible to regular scientists and engineers.
Exactly. And crucially, NVIDIA made CDA work across their entire range of GPUs, from the high-end side is access to massive parallel computation.
Can you explain the basic difference? Why is a GPU so good at this compared to our regular CPU?
Think of it simply. A CPU is like a very smart, very fast executive. It can handle complex sequential tasks really well, one after the other. A GPU is more like an army of interns. Each intern isn't super sophisticated, but you have thousands of them, and they can all do simple, repetitive calculations simultaneously.
Like calculating the color for every single pixel on a screen all at once?
Precisely. Or, as it turned out, doing the massive matrix multiplications needed for deep learning. For tasks that can be broken down into thousands of parallel pieces, the GPU's architecture is just vastly more efficient.
And NVIDIA didn't just release the software, they actively cultivated the ecosystem.
Oh, yeah. They were brilliant at this. They started the CDA Center of Excellence program, partnering with universities like the University of Illinois. They donated hardware, funded research, created course materials,
Ensuring the next generation of computer scientists learned programming on NVIDIA hardware using CUDA.
guaranteeing it. They built the developer community from the ground up, Students graduated already fluent in CEDA, went into industry or academia, and built more tools and applications on CEDA. It created this powerful network effect.
And the real-world impact became undeniable with examples like the Amber project.
That was a huge one. Amber is this complex molecular dynamics simulation program used heavily in drug discovery. Historically, you need access to hugely expensive supercomputers to run it effectively.
Right.
Then this researcher, Ross Walker, rewrote parts of Amber using Qidea to run on standard, affordable Nvidia GeForce gaming cards, and the results were stunning. The simulations ran up to 50 times faster than the CPU-only versions.
50 times on a gaming card.
Yeah. Suddenly, individual researchers or small labs could do computational science on their desktops that previously required millions of dollars of hardware and long waiting times. It completely democratized high-performance computing in many fields.
And that ecosystem, all the code written, the bugs fixed, the libraries optimized, the people trained over more than a decade. That's the CUDA moat everyone talks about.
That's the moat. It's not just the hardware anymore. It's the entire software stack built on top of it. As one former Nvidia scientist put it, trying to move a complex AI application built on CUDA over to a competitor's platform, like AMD's, is a huge undertaking.
The switching costs are enormous.
Immense. You'd have to rewrite vast amounts of code, debug it all again, retrain your teams. Jensen didn't just sell chips. He built a proprietary computational universe that, especially in AI, almost everyone now lives inside.
Which brings us neatly to the culture and leadership that enabled all this, the Nvidia way in practice. It sounds intense.
Intense is putting it mildly. It's often described as a pressure cooker. Jensen's guiding philosophy is sometimes summarized as tortured into greatness. He fundamentally believes conflict and direct criticism are essential for innovation.
Why? What's wrong with positive reinforcement?
He sees praise as potentially leading to complacency. And for Jensen, complacency is death in the chip industry. He's famous for giving feedback, often harsh feedback, in front of everybody.
That sounds incredibly uncomfortable. How do they retain people?
It's counterintuitive. Right? His reasoning is that feedback is learning. If one person makes a mistake and they're corrected publicly, everyone learns the lesson simultaneously. It speeds up organizational learning. And apparently, he doesn't actually fire people that often. He prefers to, well, torture them into greatness. His view is, if you are smart enough for us to hire, you're smart enough to take the feedback, adapt, and improve under pressure.
So it filters out people who value comfort over peak performance.
That seems to be the effect. It's designed to eliminate politics and bureaucracy, ensuring that ideas are judged on merit, not on who proposed them or who their boss is. And he applies this same brutal honesty to himself.
The story about looking in the mirror.
Yeah, even after a blowout successful quarter, he told his top sales executives, "I look in the mirror every morning and say, you suck."
Just relentless dissatisfaction, never resting on laurels.
Never. It keeps everyone focused on the future, on the next threat, the next opportunity. And this intensity translates into the work ethic. People talk about a 258 schedule. Jensen himself embodies it.
He believes you have to be obsessed.
He explicitly says you must allow yourself to be obsessed with your work. He's known for working incredibly long hours, like 9 a.m. to near midnight routinely.
And the famous vacation email story.
Perfect illustration. His team saw him sending work emails while he was supposedly on vacation with his family. They tried to stage a mini intervention, asking why he wasn't playing with his kids on the beach.
And his response?
Classic Jensen. He said something like, "I am playing with my kids. I'm sitting here on the balcony watching them play in the sand and writing emails." For him, there's no separation. Work is passion, it's integrated, it's all-consuming.
Okay, so the culture is intense. What about the actual structure of the company? It's also really unconventional. No COO, and Jensen has like 60 direct reports.
Yeah, it flies in the face of all conventional management theory, which usually advises maybe 7 or 8 direct reports maximum for a CEO.
How does that even work? How can he manage 60 people effectively?
The rationale is tied directly to that speed of light principle and transparency. With a flat structure like that, information travels incredibly quickly. There are no layers of middle management to filter, delay, or distort messages going up or down.
So if there's a crisis or a new strategic direction, he can communicate it to the entire senior leadership instantly and ensure everyone is aligned.
Exactly. It keeps everybody in sync, as one source put it. And it has another effect. It empowers more junior employees. People get pulled into high-level meetings they wouldn't normally attend in a hierarchical company. They get to watch Jensen himself reason through complex problems.
So they learn the why behind decisions, not just the what.
Right. And arguments are supposed to be won based on data and logic, not rank or title, which leads to another unusual practice, the obsession with whiteboards over PowerPoint.
He really doesn't like slides, does he?
Famously hates them. He sees PowerPoint as a way to hide fuzzy thinking. You can make bullet points look neat, even if the underlying logic is weak or the assumptions aren't clear.
Whereas a whiteboard forces you to build your argument from scratch.
Exactly. You have to be rigorous and transparent. Lay out your assumptions, your data, your reasoning step by step. There's no place to hide, as the saying goes. Jensen uses the whiteboard process to probe, challenge, and ensure absolute clarity.
And then they have to erase it afterwards.
Yes. Always wipe them away and start anew.
Yeah.
It's symbolic. Don't get attached to old ideas. Always be ready for the next challenge. Focus on the future.
All this technical rigor, this deep engagement, it's possible because Jensen isn't just a business guy, he's a technical CEO. He embodies the engineer's mind.
That's a huge advantage, especially compared to what some call the anti-Darwinian succession we saw at places like Intel or Microsoft for a time, where non-technical CEOs took over and arguably missed critical technology shifts.
Like Intel missing manufacturing transitions or Microsoft under Ballmer missing mobile.
Those are the classic examples. Jensen avoids that because he stays incredibly close to the technology. People say he often knows more about the product than you do, even if it's not your core area.
Like the Wi-Fi standard example.
Right. A former product manager recalled being grilled by Jensen on the super technical details of various Wi-Fi protocols, even though it was a relatively minor product line for Nvidia at the time. That level of diligence means he understands the trade-offs.
And it prevents decision paralysis.
Because he forces a decision. He'll push people to make a call based on the best available data, even if it's incomplete. He learned early on not to get bogged down chasing false accuracy with endless decimal points. Round up, make a judgment, and move forward. Keep the speed up.
Okay, so that culture, that structure, that leadership, it all sets the stage for the massive success they're having now. But it wasn't just about execution speed, it was also about making huge long-term bets.
Yes. This is maybe the third crucial pillar of the Nvidia way, investing in moonshots with no clear short-term ROI. Nvidia Research, founded back in 2006, was specifically created for this.
To work on things that wouldn't survive the normal hyper-fast product cycles?
Exactly. Things like ray tracing. This is a technique for creating ultra-realistic lighting and reflections in graphics. It's been a holy grail for decades, but computationally, it was just impossibly expensive. Nvidia Research worked on it for years and years, patiently, before it finally became practical to implement in consumer GPUs.
And DLSS, the AI-based rendering technique, was another long-term play.
Deep learning supersampling. Yeah, that took 6 years of continuous effort before it was ready for prime time. Jensen's attitude towards these projects is really telling.
What did he say about the ROI?
He basically said, we don't have an ROI timeline. The only thing we're optimizing for is this. Is it incredibly cool, and are people going to like it? That freedom allows for fundamental breakthroughs that quarterly focused companies just can't pursue. It's how they ultimately beat the innovator's dilemma.
And a more recent, very strategic long-term bet was buying Mellanox in 2019. That was $6.9 billion for a networking company, which seemed far afield for a graphics chip maker.
It seemed that way to some, but Jensen had this vision. He saw that AI workloads weren't just going to use 1 or 2 GPUs. They'd need thousands working together in data centers. And if you have thousands of GPUs crunching data, how do you feed them data quickly enough? How do they talk to each other without bottlenecks?
The network becomes critical.
It becomes the critical component. Jensen predicted that the entire data center would become the computer. And if the data center is the computer, then the network is the motherboard connecting everything. Mellanox was the leader in high-speed, low-latency networking, especially with their InfiniBand technology.
So buying Mellanox wasn't diversification. It was securing a vital piece of the future AI infrastructure puzzle.
Precisely. They needed best-in-class networking to ensure their GPUs could actually deliver their full potential when deployed at massive scale. And that bet paid off spectacularly. Within just 4 years, that Mellanox acquisition was generating over $12 billion in annualized revenue and growing incredibly fast.
Okay, which brings us to the final massive pivot, AI itself. When did Nvidia really decide to go all in on deep learning?
The key moment seems to be around 2013. This was after early breakthroughs like AlexNet in 2012 started showing the incredible potential of deep learning, running on Nvidia GPUs, actually. Jensen saw it. He recognized that the parallel architecture they'd built for graphics and made accessible through CUDA was accidentally the perfect engine for this new type of AI.
But it wasn't an easy decision internally.
No, apparently there was significant pushback. Some of his key leaders thought deep learning might just be a temporary fad, an academic curiosity that would eventually fade. They were hesitant to bet the company on it.
But Jensen overruled them, using that authority from the flat structure.
Exactly. He famously declared in a big executive meeting, deep learning is going to be really big. We should go all in on it, full stop.
And going all in meant more than just saying it. They had to re-engineer things quickly.
Very quickly.
Yeah.
It required intense operational focus. For example, their Volta GPU architecture was already quite far along in development.
Right.
But Jensen pushed the teams late in the cycle to integrate brand new, specialized hardware called tensor cores.
What do tensor cores do?
They're tiny processing units specifically designed to accelerate the matrix multiplication operations that are absolutely fundamental to deep learning algorithms. They optimize the GPU hardware itself for AI workloads.
And they optimize the software, too.
Critically, they poured resources into developing libraries like CUDA CUDA Deep Neural Network. This software sits on top of CUDA and provides highly optimized routines for the specific types of calculations used in neural networks, especially the transformer models that power things like ChatGPT.
So it was this combination, the underlying CUDA platform, the specialized tensor core hardware, and the optimized CUDA software layer.
That trifecta. It meant that when the AI explosion really happened, kicked off by ChatGPT's release in late 2022, Nvidia wasn't just present, they were uniquely prepared. They were the only ones with the fully integrated high-performance hardware and software stack ready to meet the sudden, almost infinite demand.
And the market reaction when Nvidia revealed just how big that demand was in May 2023, it was unprecedented.
Analysts literally described their Q1 2024 revenue guidance as cosmological. Stacy Rasgon at Bernstein said he'd never seen a guide like the one Nvidia just put up. It was just off the charts.
The biggest single revenue beat in semiconductor history.
The largest dollar revenue upside guidance in industry history.
Yeah.
The stock market reacted instantly. They added something like $184 billion in market value in a single day. That single day's gain was more than the entire market cap of their longtime rival, Intel. Just staggering.
And Jensen immediately leaned into this, marketing their massive AI systems like the DGX GH200 with a very counterintuitive slogan.
Right. The more you buy, the more you save, which sounds crazy when these systems cost millions. But his point was about total cost of ownership and performance. He argued that buying their integrated optimized system, even at a high upfront price, was ultimately more cost-effective for training huge AI models than trying to piece together something cheaper but less efficient.
He sees AI as this fundamental tool, a universal function approximator.
Yeah, capable of learning and predicting patterns in almost any kind of data. And the pricing now reflects their position as the essential infrastructure provider for this new era. Their latest server racks, the Blackwell GB200 series, are reportedly priced between $2 and $3 million each.
A long way from sub-$100 graphics chips.
A very long way. And true to form, Jensen's already looking past the current AI boom. He's drawing parallels again. He says just like the GPU revolution needed the right algorithms, fast computers, and the right expertise all coming together.
He sees the same thing happening in another field.
Digital biology.
Yeah.
He's predicting digital biology is going to be it. He believes the combination of AI algorithms, massive computing power fueled by Nvidia GPUs, naturally, and biological data is poised to revolutionize drug discovery, personalized medicine, maybe even our understanding of life itself.
Always looking for the next wave. It's quite a story we've unpacked today. Resilience, vision, relentless execution.
It really is. If you boil down the Nvidia way from everything we've discussed, you get these core elements. That fundamental belief in sheer will forged in Jensen's early experiences with pain and suffering.
Operationally, it's that ruthless commitment to speed-of-light execution, coupled with that brutal intellectual honesty and forthview the flat structure and the whiteboard culture.
And strategically, it's the willingness to constantly question assumptions, demonstrated by surviving those huge NV1 and NV30 crises, and crucially, the foresight to build that incredibly sticky CDA software ecosystem, creating that deep moat in AI.
You look at their history. They barely made it through the 90s, almost died again in the early 2000s, and now they utterly dominate their third decade. That ability to take short-term pain, make those long-term, non-obvious bets, it seems key.
Absolutely. And Jensen remains hyper-aware of the target on their back. He doesn't just think competitors want to beat him. He says, I know they're trying to put me out of business.
So, given everything we've explored, the culture of maximum effort, the deep R&D investments, the CUDA moat, here's the final thought for you, the listener, to consider. What would it actually take for a rival, whether it's AMD, Intel, or one of the big cloud players building their own silicon, to genuinely challenge Nvidia? How do you compete with a company that seems to have mastered navigating the innovator's dilemma and operates at this kind of intensity?
Especially now, when the stakes aren't just market share, but potentially trillions of dollars in the future of computing and AI. That question of sustainable advantage in the face of such focused competition, that's the big one to mull over.